Today we'll cover both lessons 80 and 81. We will just do a quick review of a variation problem. We are going to continue doing all of them with the K's, with the constant of variation, because that's the way that our science classes teach it, and the science teachers prefer that we use the K's and not the proportions. And then we'll also divide complex numbers. We've already been adding and subtracting and multiplying them, and today we will divide. So blues vary inversely. So anytime I have variation, I know that I need to start out with B equals. And who can tell me how I set up the right-hand side on that? Blues vary inversely. Charlotte. You're close. Let's flip that around. Blues vary, anytime it varies, it equals K, and then either times or divided by. If it's direct, it's times. If it's inversely, we are dividing. And so that's going to be yellows squared. Got to read carefully. Yellows squared means this. Square root means this. So read it carefully. Students mix those two up all the time, and I think it's just not reading the problem carefully. They know that you guys know the difference, but you've got to read it carefully. So then 100 blues go with 3 yellows. So everybody solve for K real fast for me. Look up at me when you have a K value. And I'll count to 3. Everybody shout out what K is. 1, 2, 3. Excellent. So K is 900. So our actual formula for this problem is B is 900 over Y squared. Now we want to know how many blues. If we have 10 yellows, so we put 10 in for the Y. Everybody solve this real fast. And then I'll have you shout out your answer on that one also. 1, 2, 3. So 900 divided by 100 is 9, and label it 9 blues, not just B equals 9. Any questions with that? Inversely means one gets bigger, the other gets smaller. One gets smaller, the other gets bigger. That's how an inverse relationship works. Direct, if one gets bigger, the other gets bigger. If one gets smaller, the other gets smaller. So so thanks for that question. That's a good review of what the English words actually mean is going on. All right, lesson 81. Do you agree that the top is a complex number? The bottom is a complex number. And a fraction bar is one way of writing division. So this is one complex number divided by another complex number. We are going to use the very same method that we did with square roots. We are going to multiply numerator and denominator by the conjugate. So the complex conjugate would keep the real part the same and change the sign on the imaginary part. So we need to multiply numerator and denominator by 3 plus 3i. And it is just a matter of foiling and simplifying. So I need a little bit of help. So Hendrix, would you tell me what to write down as we FOIL the top? And let me write it first as plus 9i squared just for emphasis. So everybody thumbs up, thumbs down. Did we get this right? Denominator. Grayson, would you help me do the multiplying for the denominator, please? How do you get a 6? 3 times 3 is, okay? So everybody good with that much for the denominator so far? Because we know when we multiply with conjugates, the O's and the I's cancel out, so we just have to worry about the first and the last. Both of those I squares are how much? So that one is really a -9, and this one really becomes a +9. So what does that leave us in the numerator? Beck. And I love that you got the I last on that. And denominator, everybody? Okay, one more step. Maybe two. Got just a number in the denominator. Is it a positive or a negative number? Is that what we want? Is there a GCF of everything that we could cancel out? Charlene, help me with that. They're all divisible by 3. So because my numerator is 3 times -1 plus 5i, and my denominator is 3 times 6, you can cancel factors. You can't cancel things that are added. So final answer is going to be -1 plus 5i over 6. So can I leave it like that? What's wrong with that? There's something we still need to fix. Ted? Nope, I has to go last. What's the other thing that's wrong with it? Kevin? I have it with one long bar, but that is not okay. I have to write one real number, and then the plus or minus sign, and then one complex number. So I need to write that as -1/6 plus 5/6 I. So I could also have gotten there by saying -3/18 plus 15/18 times I. Oh, now I'm going to simplify both of my fractions. So 2 ways that you could get there. Anybody with a question on that? Okay, then let's divide this. So can I write division with a fraction bar? So that's where I want you to be careful. Don't try to set this up with a little house thing, with this kind of symbol. That's going to confuse you. Set it up that, oh, that is 2 minus 2i over 2i minus 2. So now we need to multiply numerator and denominator by what? How are we going to set that question first? I could, but then I'd still have 1 minus I and I minus 1. So I'd still have an I in the denominator. You can't leave an I in the denominator. Just like you can't leave a square root in the denominator. But yes, you could simplify it and use some smaller numbers if you wanted to. So who can help me set this up? What am I going to multiply numerator and denominator by? Some of you who haven't answered yet. Evelyn, what do you think? So we can change that sign and multiply by 2i plus 2 over 2i plus 2. And that will give us, who wants to help me FOIL the numerator? Sure. A little louder, please. 4i. Everybody good with that so far? And denominator, what am I going to get with my denominator, Austin? Well, let's leave the I squared in there for right now, just to make sure everybody follows. So the 4I squared minus 4, and then both of those I squares are really minus 1s, which means that we have what in the numerator? Somebody help me out here. What do I have in my numerator? Ricky, what do I get? So the 4I minus 4I cancels. The 4 plus 4 becomes an 8. And then what do I have in the denominator? Everybody. And what's 8 over negative 8? So does that make sense to everyone? Now I want to point out, Ted's already mentioned one way we could have done this. We had some other choices. We could have said that this is 2 times 1 minus I over 2 times I minus 1. We could have canceled that. Then we could have said, oh, that thing we've been doing with take the minus sign. If we take 2 minus signs, I could have changed this to a 1 minus I by multiplying it by minus 1. So I'd need to change the sign out in front, keep the numerator. Oh, those would cancel, and I'd have negative 1. I could also have said, wait a minute, that denominator isn't written correctly. Should have been 2 minus I over minus 2 plus 2I, and maybe I could have noticed the same kind of thing there to get the i's last on both. I could have multiplied numerator and denominator then by minus 2 minus 2I, changing the sign in the middle. Looks a little different than what I multiplied by, but I would get exactly the same thing if I did it that way. So you've got some choices, which I wanted to point out. So questions from anybody on any of this? Okay, most of you already have the paper that you picked up the other day, but let me get that handed out to everyone. And then I want to check these to make sure we're understanding what's going on.